Your Highness, Your Excellencies, dear ladies and gentlemen, welcome to the Digital Airport Show. My name is Peter Gridling. I'm pleased to introduce you in a real interesting topic. So first I have to share my screen. So I'm pleased to introduce you in the topic of developing resilience with ATM networks and smart digital towers in a remote and busy airports. So Frequentis is one of the leading companies worldwide providing remote tower technologies. Basically, we are not doing that since yesterday. So we have started almost 20 years ago with developing the first concepts, and we have more than 20 years of research history in developing and researching remote tower technologies. And since 2017 now, we are permanently rolling out different kind of digital and remote towers, so that we got in the meanwhile to the world leading provider of digital and remote towers. So when we are looking at our references, then you will see that remote tower technology is not only about remote towers, it also includes digital towers where you control airports which are not remotely controlled but controlled from on-site, or even vision enhancement solutions where the control of the remote tower technology is used to be by the EDCOs in the tower cabin as a vision enhancement. And last but not least, we see today that remote tower technology also is used at large hub airports. So it's not only for small airports, it's also for large airports where it's used for contingency solutions and also for to increase capacity for such large airport operations. So in the past, we have spread out our solution really worldwide. So we have started in Vienna in Austria with an apron control system, but then we also implemented Saarbrücken Airport in Germany with the first regional airport which is remotely controlled and which is currently the largest remotely controlled airport worldwide. We have also implemented a contingency system in UK at ports of Jersey. We also have a very small system, a remotely controlled AFIS airfield in the very northern part of Iceland. We have rolled out systems in Argentina for vision enhancement, and Brazil, a military civil airport where it's used as a digital tower. We have also contracted 2 projects in New Zealand, one remote tower in Invercargill and a contingency system for Auckland Airport, which is a large airport. And last but not least, we have also proven that our system is capable to be used in military environments. So the US Air Force and the US Navy are customers of us and using and evaluating right now remote tower technology for airfields, but also as a deployable solution. So you see, you can use remote tower technology in a very flexible way. And I personally believe that in 10 to 15 years, we will see digital and remote tower technology basically on every airport worldwide. Of course, with different use cases, but you will find this technology basically at every airport. Yeah, now, what's the motivation of implementing digital and remote tower technologies? First of all, it all started with cost savings and with increasing efficiency. So, and what we have proven in the past is that our customers can save up to 18% of the operational costs in their operations. But when it comes to building new towers, to renovate towers, then our customers save even more money. So in Germany, for example, in Saarbrücken, the tower was end of life, and DFS, the German ANSP, has decided to replace the old concrete tower with a remote tower. So here they saved almost 80% of the costs compared to an equivalent concrete tower. And last but not least, the advanced possibilities, the advanced features of a remote tower system can even increase the level of safety, especially on smaller airports. But what we have seen in the past months was that remote tower technology can not only support you in cost savings and increasing efficiency. We have clearly seen now in the past months during the pandemic crisis that remote and digital tower technology can even support you in a lot of other situations. If you can remember what when I have spoken about the references before, I've told you that Auckland Airport has decided to implement a contingency system. And interestingly, the motivation for them was a natural disease. So basically they had a heavy earthquake in 2015 and the concrete tower was damaged. So they had to evacuate the concrete tower. And of course, they had contingency plans in place, but during the week, they had to check if the concrete tower is still okay and that they can again operate the airport from the ATC tower. They had to reduce the capacity by 50%. And this is only one example beside of many. So think about terrorist threats, think about fires, think about natural diseases like volcano eruptions, like earthquakes. So there are a lot of situations which can happen and which would affect your operations and can stop your operations and force you to close the airport. And to avoid that in the future, Auckland has implemented remote tower technology. So if that would happen in the future, they basically would evacuate the tower and then move the air traffic controllers to a control room and take over control from there. And what we have also proven in the past is, especially in the past months, is that social distancing measures for the pandemic situations as we have it today can much more easily executed in a remote tower environment and then in a remote tower control room as in a tower cabin. The tower cabins are often very small, very compact, and in a control room you can much more easily implement social distancing measures to keep up the operations and to avoid that air traffic controllers are infected and that you have to reduce the operational capacity of your airport. So that what we have seen now in the past months, that remote and digital tower technology can be used for a lot of different airports, and I'm convinced that also in the Middle East in the future, to keep up the large hubs like Dubai, like Doha, this technology will be implemented into the environment of those airports. And when we are talking about remote towers, then we are talking basically about different camera technologies, including infrared, different sensors at the airport. So this is basically those sensors and those cameras are used to provide to the EDCO exactly what he has right now. So a panoramic camera system is replacing the out of the window view of the controller, and high performance pan tilt zoom cameras are replacing the binoculars of the controllers. But also all the other data the EDCO has available in a tower has to be transmitted into the remote tower center. And to enable that and to guarantee that, the network between the airport and the control room, the control center, is of essential importance. So here, if you have an issue with the network, then basically that could mean that you have to close the airport. And Frequentis is providing a special product, a special solution to provide ATM grade performance for the network, regardless what kind of network you're using. And to introduce you that technology, I will now hand over to Matthias Gerlich, who will introduce you in this topic of ATM grade network.
So thank you, Peter, for introducing myself and the remote tower solution of Frequentis. I will now introduce the ATM grade network solution. Therefore, I will share my screen. Peter already introduced the remote tower, but as mentioned earlier, also the network in between, when it comes to such application, is even more important than it was in the past due to various new conditions that we are facing. So why do we talk networks at all today? The ANSPs, they're introducing new applications to their network, which have completely different requirements as it was in the past. For example, the remote tower solution. Classically, ANSPs were used to narrowband applications such as voice, radar, data transmissions as flight plans. But now with the remote tower, we are introducing broadband applications for video, depending on the resolution, with a lot of more content that needs to be transmitted over the network as it was in the past in a more heterogeneous environment. Also swim applications, virtual centers. These are all applications that depend very much on an infrastructure, on a network infrastructure that supports the application in a way the controller at the end of the day or the pilot expects the application to work. So therefore, we introduced at Frequentis the ATM grade network concept that we have deployed in several countries around the globe already, with the biggest deployment and total IP-based network in Brazil. When we look back into the infrastructures, we had a traditional approach, which was a silo-based approach. That means all applications, if it was voice, if it was surveillance, if it was administrative traffic, they had their own networks, which were fairly easy to maintain, but cost effective or very cost inefficient. But now we need to change to a new approach into a converged IP network approach, where all the applications share now the bandwidths. That means we create a higher bandwidth efficiency, but what we take away with these IP networks is the deterministic approach that the ANSP was used in the past. What Frequentis is doing is an ATM grade IP or hybrid network approach, where we increase now not only the availability by certain mechanisms that we're implementing, but also lower the operational cost by, for example, reducing the overall bandwidth by still keeping the determinism the ANSP was used in the past. So what we do with our networks, we're introducing intelligent routing and control. That means we make sure that the package arrives at the destination the packet shall go to or is intended for. We bring scalability to the network, no matter what application you're using, no matter what devices you're using in the network. We are providing a performance that ensures an end-to-end availability and performance that the ANSP expects. Further on, we are introducing situational awareness with an end-to-end monitoring, not only seeing devices, but also seeing if the service is transmitted with the performance that it is expected to perform from an end-to-end perspective. That all together with an end-to-end design allows the customer in the future to enable all applications via one network with the performance expected. Talking about the remote tower and the importance of such applications, we have introduced connectivity with certain features for remote digital towers, and now not having people on premises anymore, like it was in the past, people controlling airports, airfields from a remote location. And therefore, we have to ensure that even more network availability is granted, that passengers and aircrafts will arrive safely at the airport. So therefore, we have a video that I wanted to introduce you really quick. We have on the right-hand side a remote airport where you see an aircraft landing. We have on the left-hand side a typical remote tower center with the main screens to control the airfield, but also with support screen capabilities such as infrared, touch panel, and voice panel. So on the left-hand side, we would simulate here a remote tower center where the controllers are sitting controlling the remote airport. In between, on the bottom, we have a network infrastructure for two networks in that case. The primary one could, for example, be an IP MPLS network. The secondary network on the top could be, for example, a VSAT network. That said, when we look into the infrastructures around the world, we have very hybrid approaches here that takes various transmission technologies into consideration. So in the event that we are experiences in the Frequentis solution, for example, bandwidth issues, like on the left-hand side, the system is on a currently probing mode. That means we're measuring the performance of the network on a constant basis. And in the event that the application is not supported in the way that the network should perform, we have incorporated a mechanism called brownout detection, that we're switching links even before a network failure would occur and switch to an alternative network. That means we have a proactive approach, switching from one network to another network when network performance is not met anymore. So in that event, we experienced on the lower network, on the IP network, a network issue and network problem. So what happened was we switched to an alternative network, which could be the VSAT network, which has much less bandwidth available due to cost of these networks, and switched to a smaller network is mentioned. So what also happened on the left-hand corner, not only did we switch the network, but knowing now that the bandwidth is limited, we also via the net broker deactivate the support screen. That means we are transmitting less data now, less video, saving bandwidths, and ensuring again that the picture quality for the controller is as good as he expects it to operate in a safe and secure manner. So the next picture or the next video demonstrates now that even though we have switched the network, we are experiencing more issues on the VSAT network, for example, bad weather conditions, and we are transmitting again on a limited data rate. So what we do is we have to reduce bandwidth again, and therefore we are putting for the controller at the remote tower center a video slicing on. That means we are not transmitting now anymore the full video content, but we're limiting not only the support screen or deactivating the support screen, but we're also limiting now the picture that the controller sees, still good enough to operate the airport remotely. Now that the actual network, the primary network, is back in full operation again, what happens will now be the net broker detects the primary path, that means the former IP MPLS network is back, and it switches automatically back to the broadband network. That means not only will we now see the full screens again, we also activated again the support screen and all applications as it was before. That changing from the secondary to the primary network is completely automated and will not require any operator intervention. So what is the benefits? What is in for you? By introducing the ATM grade layer via the VitalSphere net broker, We can combine now all applications over a single network platform. That means we can have the voice communication, remote tower applications, surveillance, but also applications such as SWIM or administrative traffic on the same network. By introducing mechanisms such as brownout detection, deterministic prioritization, and graceful degradation of certain services, we can also ensure that all applications are transmitted via narrow-banded networks in the way that the customer expects it to be. We are increasing the amount of service classes. That means the most important applications will always be served first. That said, we are also increasing the availability of the overall solution. That means we're guaranteeing the highest operational experience for the users. Your Highness, Your Excellencies, ladies and gentlemen, we would like to say thank you in the name of Frequentis participating in the webinar today and look forward to discuss our solutions with you in the near future. Thank you very much.